This video is going to help you with Tuesday's math lesson. The title at the top of Tuesday's math paper is Equivalent Fractions Pattern. And so you're going to do some of those and then some review problems. So you're going to have some problems that look like this, that have a series of fractions, although your fractions aren't written with the slash. They are written with the 5 at the top, the line in the middle, and the 8 as the denominator. I can't figure out how to do that in Word, so mine have the slash. I do prefer the line, just the horizontal line, with the numerator 5 at the top, the horizontal line, and the 8 as the denominator. I just think it's a little clearer. So anyway, you're going to see similar problems like this. And what you're being asked to find is the pattern. You're looking for a pattern in the numerators, like these numbers right here that I'm hopping to. And then, of course, this is a blank. And then this is the numerator. Or the denominator. Hopefully, you will find a pattern in both. So if we look at this top problem, this line of fractions right here, and we're going to look at just the numerators, which are the top numbers. So we have 5, 10, 15, blank, 25. So based on that pattern, 5, 10, 15, what would logically go there? And I hope that you've said 20. 20 would be the logical thing to go there because that follows the pattern 5, 10, 15, 20, 25. And then we know that to go from 5 to 10, we would multiply by 2. 5 times 2 is 10. And so then if we multiply 5 times 2, we're going to have to multiply the 8 times 2, and 8 times 2 is 16. Look, that's what's happened here. So then if we say 5 times 3, we get 15. 8 times 3, we would get 24. So these are all equivalent fractions that stem from this first fraction. So knowing that we've counted by 5s up here on the top, and we've counted by 8s down here on the bottom, what is going to go there? So we've done 8 times 2 to get 16, 8 times 3 to get 24, 8 times 4 to get 32, so it will be 8 times 5 here to get 40. So I hope that you see that pattern there. And these are all equivalent fractions that stem from this original fraction. So let's look at this next row of fractions. We have 1/4 is equal to, we're not given numerator or denominator here, so we're going to have to think on that. And then we have 5 20ths, 7 28ths, and 9 something, 9 over blank. So let's look for some patterns with the numerators first. So we have 1 here. We're not sure what goes there. 5, 7, and 9. So if we look at that as a pattern, 1 blank, 5, 7, 9, what do you think goes here? I hope you said 3. I hope you said, I can see that they're counting by odd numbers here. 1, 3, 5, 7, 9. All right. Now we can go back and use some multiplication to help us, or we can just look at patterns and we can say 4 blank, 20, 28, and blank. You might notice the difference between here is 8. So how's that going to help us? I think I would be better off if I went the multiplication route. If I said, okay, I know that 1 times what will give me 3? I know 1 times 3 will give me 3. So I'm going to say I have to multiply this bottom number times 3, because whatever I do to the top, I have to do to the bottom. So 3 times 4 is going to be 12. All right? And now we have 4, 12, 20, 28. We said earlier, well, I noticed that the difference between 20 and 28 is 8, so they counted by 8s there. How about from 12 to 20? That's also 8. And how about from 4 to 12? That's also 8. So 4, 12, 20, 28. We know we're going up by 8s. So over here, we're going to have 36. And let's look at what we did as far as multiplication goes. So we said 1 times 3 is 3. 4 times 3 is 12. 1 times 5 is 5. 4 times 5 is 20. 1 times 7 is 7. 4 times 7 is 28. 1 times 9 is 9. 9 times 4 is 36. I wrote that in there wrong. So you can figure this out using multiplication, but also looking for the patterns. The patterns are helpful as well. These are all equivalent fractions that stem from this 1/4 fraction. Another thing that I'm sending along in your work packet this week is a colored fraction paper that shows 1/2, that shows halves, thirds, fourths, and that can be helpful in some of these problems as well. So let's take a look at this one. We have 1/7 is equal to how many 14ths, is equal to how many 21sts, is equal to 4 something, or 5 35ths. So let's see what patterns we find in the numerator. So we have 1 blank 3 4 5 as our numerators. So looking at that, what numerator do you think goes right here? We have 1 blank 3 4 5. I hope you said, 2. Now we have 1 2 3 4 5. 1/7 is equal to 2 14ths. What did we do to go from 7 to 14? Well, we added 7, or we counted by 7s, or we doubled it. So look here, we have 7, 14, 21, and what's going to go here? I hope you notice that we're counting by 7s there. So this is going to be 28. So we have 7, 14, 21, 28, 35. And these are all equivalent fractions that stem from this first fraction. 1 times 2 is 2. 7 times 2 is 14. 1 times 3 is 3. 3 times 7 is 21. 4 times 1 is 4. 7 times 4 is 28. 1 times 5 is 5. 7 times 5 is 35. So you're going to have similar problems to that on your worksheet. Look for the patterns. Use multiplication to help you as well. And then these fractions here are all equivalent because they stem from this same original fraction. The second part you have on there, which I believe that you've already done these, but I just want to review them a little bit. You have to write 2 equivalent fractions for each one of the fractions given here. So if you recall, when you write equivalent fractions, you have to multiply the numerator and the denominator by the same number. So I always say start at the beginning, okay? So 2/3, I don't want to multiply by 1 because when I multiply them by 1, I'm going to end up with 2/3. So I'm going to start with 2. I'm going to multiply numerator and denominator by 2, and I'm going to end up with 4/6. 2 times 2 is 4. 3 times 2 is 6. So that is 1 equivalent fraction for 2/3. And then I'm just going to stick with the easy things. I'm going to do 3 next. 3 times 2 is 6, and 3 times 3 is 9. So these are 2 equivalent fractions of that. Again, they're equivalent fractions that stem from this fraction right here. And I could say, well, I'm going to multiply by 100 and say 200 over 300, and that would be fine. That would work, but to me, I like to just start at the beginning and stick to the easier things. So now we want to come up with 2 equivalent fractions for 3/5. So I'm going to use 2 as my multiplier. 3 times 2 is 6, and 5 times 2 is 10. And then I'm going to say, okay, 3 times 3 is 9, and 5 times 3 is 15. So here are my equivalent fractions for 3/5. And then the last one that I have to do is 4/7. And again, I'm just going to go with number 2. I'm going to say 2 times 4 is 8, and 7 times 2 is 14. And then 3 times 4 is 12, and 7 times 3 is 21. So these are my 2 equivalent fractions that stem from this fraction. So I hope that is helpful on your worksheet. I believe the rest of the worksheet is review. So good luck.